Hello. In this session, we're going to look at subnetting IPv4 addressing. This time with class A. Let us assume that we have this IP address 10.0.0.0. So /8. So with /8, it means that the subnet mask. Okay, right now with /8, it means that there are 8 ones, either 5, 6, 7, 8, and then the rest of the subnets of the octets are zeros, and this in the decimal format, it's 255, then .0.0.0 like this. So with this one here, we can actually try to answer the 6 questions. One, here, as you can see, we have the prefix, the slash notation, we have the binary form, the subnet mask in binary format, we have the subnet mask in decimal format. Now we can find maybe the host, the borrowed bits. The borrowed bits equal to none. So we have 0. So the host bits equal to all these the zeros. So there are 1, 2, 3, 24. The number of subnets equal to 2 power borrowed bits. The borrowed bits we have 0, which gives us 1. That with this subnet, mask, we'll be able to have only one subnet. Okay? And then the number of usable IPs or hosts is equal to 2 power host bits, and there are 24. Here you can find out the number. The usable host, it's 2 power 2 power. So it's 2 power 24 minus 2, and then the results here you will find out too, because we are not going to use them anyway. Then how about the magic number? Magic number is equal to 2 power host bits. The host bits in octet boundary. Our octet boundary that we are dealing with, it's this. We are dealing with this octet here. So the host bits in our octet boundary, they are 8, which gives us 256. Let me see now what we have. That we have this as the first, second, third, fourth, fifth, and then sixth. Okay, so from here we can actually populate our table. Let me see if I can follow here. This we have our table. That this network address we have 10 then .0.0.0. This is /h, which is equivalent to 255 as in the subnet mask. Its subnet mask here it is 255 in this format, then .0 .0.0.0. So the first usable IP address, it will be 10.0.0 then .1, and then the last, remember the magic number. So in case, let's say I want to have the other I want to have the next subnet here, it would be 10, because I need to add, I need to I need to add. So it is 10.0.0 then dot 0. So I will add 255 in this octet because it's 256, because this is the octet boundary that we are dealing with. This. Okay. So if I add 255 on this, obviously I will get I will get 11, because this one here is going to reach the maximum limit, and then it will become 11, then dot 0, dot 0, dot 0. Still it will be slash 8. So if I subtract the 1 here, be here 1 minus 0 minus 1 impossible. Go to this, borrow 1. It is impossible. I can't borrow 1. This, it is impossible. I will borrow 1 from this. If I borrow 1, automatically I will have it. I will remain with the 10. And once it crosses to this, it will be equivalent to 256. And then I borrow 1 and then remain with 255. And then if I borrow 1 and it comes here, it will be equivalent to 256, and then that is where I will borrow 1. Still I will remain with 255, and then a 1, when it comes here, it's 256 again. I will subtract the 1 and then remain with 255. So that is our it's our broadcast here, which is 10.255.255.255, like that. So if I subtract the 1 here, I'll just copy this to save time, and it will be 254, like this. So this is our subnet. From what we computed, so this is it. Then in the same example here, now we have 10.0. Actually, this time, the next one, I will not use this exactly. So this time we have 11.0.0 and then .0/8. But we would like to subnet this network into 4 equal subnets. So this is the network, but we want to group it. Our wish is to group the network into 4 different, into 4 equal subnets in size. Subnets in size, meaning that each subnet, all the 4 subnets, they should have the same number of hosts per that network. So we're going to use the other formulas, you still know them. Since the number of, here we have it's 11.0.0.0, and then our subnet mask in binary format, because when you're subnetting, we need subnet mask in binary format. So there will be 8, and then the 4, and okay. So once we have this, then automatically we can actually find the number of subnets. Number of subnets is equal to 2 power borrowed bits. Now the borrowed bits here, The borrowed bits are unknown, eh? But we we know the subnets. The subnets are 4. The subnets are 4. So I'll just substitute here. Number of subnets is equal to 4, then power x. The borrowed bits, we don't know them. The one that can actually give us a 4. So we're going to introduce powers. It's 2 power 2 that gives us a 4. So the bases cancels, and then we remain with x is equal to 2. These are borrowed, the borrowed bits. So once you have the borrowed bits, now we have to have them here. So the borrowed bits, since there are 2, we're going to add this one here, it has to change, and then this. So this is the subnet mask that will give us four different subnets, all of the same size. See? So after getting this, then we can answer now the other one. What's the subnet mask? The subnet, what's the subnet mask? Because here now that we have, okay, the slash notation, this time it's going to be slash, because you just count. These are 8 plus this, it will be slash 10. If I'm to have the subnet mask in decimal number, it will be 255, then dot, because this there were 2, this. So this is 128 plus 64, it will give us 192, then dot 0 dot 0. So this is the subnet mask that we are going to use onto all the 4 different subnets. All the 4 different subnets. So we can continue and then look at the borrowed bits. We've already, we know them, that the borrowed bits are 2, 2. The host bits, the host bits are 22. Are they 22? So you just count these ones here. So these are 6. There is 16, then plus 6, 22. And then number of subnets, we know them that there are 4 subnets. It is 2 to power 2. These are borrowed bits and gives us 4. Then number of the usable hosts is going to 2 power, but we are not going to use them anywhere, but all we need is just to know. So it will be 2 power 22. Okay. And then the magic number. The magic number is going to 2 power host bits. The host bits in an octet boundary. And our octet boundary, it is this one here. Is our octet boundary. So the host bits in this octet boundary, they are 6. So I will come here, the 2 power 6, giving us 64. So this is the difference between the 4 subnets. So once you have all this information, then you can populate the table. And the table, it's here. So this is our first address, which is this. We simply add the 1 here. Okay. And then we can actually still add, because now the if I add the magic, because on this, if I have let's see where I can write. As if I have my 11.0.0.0. I will just, if I want to get the last the last usable IP address, I will just add the magic number on this. But the magic number I'm going to add, now that it's a 64, it is a 64. So the answer that I will get, I will just subtract a 1. Because this one here, it will take me to another, because as you can see, it will be 11 dot this, then dot 0 dot 0. So this is another subnet, or it's another group. So I cannot maintain. If I add the magic number on this, here it was 10 dot, oh sorry, 11 dot 0 dot 0 dot 1. Now I need the last, so it will be 10 dot, I will add the 64 on this and that gets 64. Then once I get 64, I will subtract the 1. If I subtract the 1, I will get 63. And then write 255, then dot 254. I subtracted the 1 here, because if you count from 0 to 64, this, from 0 to this, you will have your 64 address. But if you count up to this, you will have 65. That's the reason why I subtracted the 1. And then still here, I have to subtract the 1 because it's the usable. It's the usable. So after that, I will have 11 dot 63, then dot 255 dot 255 as the broadcast. So still here, I can do the same by 11, then dot 64, because it's the first, dot 0 dot 0, oh, dot 1, yeah. If I want the last and then broadcast, I'll add 64 here and get 128. The 128, it will be this side, 128.0.0. So once I get 120, after 128, I will subtract the 1 and then remain with this 127, then dot 255, then dot 254, because it's the address, then the other one, it will be the broadcast, 127.255, then dot 255. I hope it makes sense. If it doesn't make sense, then you will tell me when we meet physically. So this is it. With this, it will be 263, then dot 255 dot 254. So the broadcast, I will just add this and then get that. So the next here I can actually populate that it will be 11.64 and then dot 0 dot 0. And then the other one, it will be 11.128.0.0. And then I can go ahead, put 11.192.0.0. dot 0. So when you look at this, I can even put the slash, because the slash here, it will be slash 10 slash 10. So when you look at this, that what we're changing, it's this octet here, this one here. Then we have this, then it's this. It's these that are changing in grouping, in grouping. So when it comes to this, I will just be copying. You just copy this and add the one. Add the one in this. Copy this, you add the one. Copy this, you add a one. So that the first, these are first IP address in each subnet. And then when it comes to the last one, I'll just copy this and then keep changing. You look at this, it will be 120, 127, 127. And then this will be, because if I it will be 191. And then on this, it's going to be because if I add on 192, if I add 64, then I'll get 256. Then 256, you subtract 1 and remain with 255, like this. And then after that, I'll just keep copying this, I add the 1. Remove this, you add the 1. Gives you this. Then this. So that is our subnetting. So these are our four subnets. So we started with this. Then this is what we've divided into two, into 4. Into 4. So if I add the 1 here, then automatically it's going to give me 12 here. Because this one here, as you can see, if I add the 1 on this, which is 255, it will be 256. It's maximum. You write a 0, you keep 1 here, and still it completes it to 256. You write a 0, you keep 1. Still it's the same. You write a 0, you keep 1. It makes it a tradable. So all these other ones, they will be 0, 0, 0, like that. So now in this, I'm giving you assignment that you work on this. Slash, I'll just give it a slash pin. So work on it. If it's slash 13, populate this table. populate this table, but don't forget the other question. A number of host bits, number of bold bits, number of the subnet, the number of subnets, the magic number, usable hosts, all that, and then after that, you generate this table. You generate this table. I think that is it. Thank you.